Right, so there's a new section available to you in the website, and the topics for this week are the same as last week. It's more on navigation and more on design patterns. The reason I'm covering it this way, the reason I split up both of those topics across 2 weeks was kind of dictated by the labs. In last week's lab, we needed to know a little bit about navigation and a little bit about design patterns. And the same is true in this week's case. The obvious thing might have been if I covered all navigation 1 week and all design patterns the second week, but it wouldn't have aligned itself with the lab. So that's why I'm kind of splitting it up in the way that I am. Right, so let's continue on our discussion on how we implement navigation in React. And navigation is this idea of the ability to have multiple views or multiple pages in your app. And the way it works is consistent with the kind of first principles of the web, which is when your browser's URL changes, then you want a new view to appear or a new page to appear. And typically we trigger that by means of some sort of hyperlink within our app. So we click on a hyperlink that changes the browser's URL address. That's essentially modeled as an event by the browser. So the browser fires that event. And what we do from a React point of view is we write routing configuration, which is what I called it last week. But essentially that routing configuration, which is written in a declarative way using various components provided by the React Router library. But behind the scenes, really what that routing configuration is event handling logic for when the browser's URL changes. And as we know from last week, what happens is the routing configuration essentially expresses what component should be mounted when the URL in the browser has a certain pattern to it. And that has the effect, really, that component that is mounted typically would have many subordinate components emanating from it. The net effect from a user's perspective is that the most of what they're seeing on the screen changes. So we know how to do the basics of it from last week. What I'm showing you here is your typical web app layout in the sense that typically there is a permanent or constant part and a variable part. And it depends on, from app to app, the degree to which parts are constant. But typically anyway, there's a kind of a header, which we might call a website header, and that remains constant as you move from page to page. There may also be a page footer that remains constant. There may even be a site menu. So these three, some or all of these three elements remain static, if you like, as you move from page to page. And it's only typically this area of the screen that's changing. So the question is, how do we achieve these kind of static aspects in a React app? And it turns out that it's the React router handles this issue. So by way of example, this is another one of the samples now that I gave you from last week. This is, I don't have a sample number there, but what I want to achieve in this particular sample is I want each page to have this header and this footer. So as I move from page to page, so here's another page screenshot, and it also has the same header and footer in it. So we implement the header and footer as ordinary React components using whatever library you want to. They could either be custom components. What we will do in the labs is we will implement them using Material UI. I think in the sample that I included with the various routing samples, I implement them using just plain old CSS and maybe some Bootstrap as well. But from a coding point of view, so here's this screenshot, I'm showing you the routing configuration for this particular sample, which is sample 6. Maybe if I just kick it off. npm start. So here we go. Here's my home page. And as I navigate around the place, the header remains constant, and the footer at the bottom as well. Yeah, so from a coding point of view, you essentially, you can include custom components or components of your own within the routing configuration. And the two that I'm using to achieve that permanent header and footer is this component here and this component. And these are, as I said, these are just two components that I've written myself to generate what you see on the screen there. There's nothing special about them other than that. You can look at the code for them yourselves. You will also do the same in this week's lab, so you can delay it until then if you want to. So it's as simple as that, really. And kind of as the routing configuration indicates now, no matter what, no matter which of these routes is currently active, the header is always going to be present on the screen and the footer is always going to be present on the screen. So we can mix custom components in with the routing configuration. And this is probably the only use case for that. React Router calls them persistent elements or persistent components. So that's that. The next aspect of the React Router library is an alternative form of the root API. So far, the form of the root API, the root component that we've used is this one here. And we know how this kind of works now, right? When the browser's URL changes, as I was saying there at the beginning, when the browser's URL changes, the React Router consults all of these root entries in its routing configuration, compares the path part to the browser's URL, and if it matches up, then it mounts this component onto the DOM. The question arises though, what if I want to pass some props to this component that's going to be mounted? I have no way of doing it using this particular form of the root component. So there is an alternative form of it, and this is the alternative form. So again, it takes the path prop, which serves the same purpose as before, but instead of the component prop, we can pass it a prop called render, and that expects to receive a function, and the function, it must return the component that you want to have mounted, but because you now write this function, you have control over the instantiation of that component and effectively passing any props that you want into it using the normal kind of syntax that we've seen so far. There could be other logic within the function as well. Maybe the logic would be concerned with computing those additional props, those custom props that you want to have passed in. So, and I think we will see this in action in this week's lab as well, but by way of example, so we're talking about sample 7. Now, unfortunately, sample 7 relates to sample 4, which we saw last week, but the essential aspect of sample 7 was, or is, there's a stats component. And when I was using the stats component last week, I was using it in an entry like this. I wasn't passing any special props into it. But this week, what I want to do is I want to be able to pass some custom props into it. So this was the way I used it last week. This is how I'm going to use it this week. And you can see here, here's my render, and here's my my function written using the arrow style. Now I don't have any logic in the function, but the function, did I mention that the function has to return the component that you want to have mounted? And here in my particular case, the custom component that I want to pass into the stats prop, Maria, this is statistical information about the user's inbox, you know, how many in messages they received, how many, I'm not too sure what my rationale for the values are, but either way, anyway, it's an array of data that I want to pass into my stats prop, which presumably it renders in some way. Now, these are hard-coded, but maybe they would be computed. They could be computed here within the function or computed elsewhere. That doesn't really matter. What's going on over here is, this is the spread operator we had from last week. Essentially what I'm trying to achieve here, as well as the custom prop that I want to make available to the stats component, I also want to make all of the props that would normally be available to the route component itself. You see, what's going to happen behind the scenes is the React router is going to call this function, and it has the option of passing a props into that function, and that may be useful to us in some instances. Now, the props that we want to pass down to our stats component is the same prop object that would be available to the route component itself. And that's essentially kind of what I'm trying to do here. I'm taking the props object that's passed into me as an argument, and it's managed by the route component itself. And I'm taking that props object, I'm spreading out its individual key value pairs, and I have to wrap that in curly braces because this all needs to be evaluated at runtime. So that's really, it's a bit of boilerplate really, and in many cases it doesn't have a significant role, but in some cases it may. Okay, so that's what's going on there. So the render prop function argument is the, oh yeah, that is essentially what I've just been saying to you there now. Here's the actual stats component itself. We had it last week, and you can go back and look at it yourselves, but this stats component, for example, well, okay, down here, okay, it's where it's accessing the usage prop that was passed into it, this custom prop. There's nothing terribly interesting there, but it's also using, as it turns out, props.match.params. Remember, that was the parameterized URL idea. Now, the match prop would not be available to this stats component if I had not done this up here. If I had left this out and only passed in the usage prop, then this expression here is going to evaluate to undefined. Okay, so there's a bit going on there now, but you should refer back to sample 4 from last week, remind yourself of how that worked, and then relate it to sample. The only difference between sample 4 and sample 7 is I essentially, if I go back one slide, I changed the routing. It was a nested route entry that I coded like this last week. Now I'm coding it like this. And the actual stats component itself has just I've added one line to it. The overall idea going on here now is when you've got a route entry and that route entry wants to mount a component, but you want to pass some custom props to that component, then if that is the case, you should use this alternative form of the route component. Next is programmatic navigation. So far, the only way we can navigate around our app is using the link component, which essentially implements a hyperlink. But sometimes you want to be able to implement navigation programmatically. In other words, code it in your JavaScript within a component. So the component's logic makes some sort of navigation or routing decision inside it. How do we code that in JavaScript? And there are two styles available to us, and in most cases you can take either one of them. In some cases you may have to take one over the other. The two styles I'm saying there is a declarative style or an imperative style, and in most cases, as I said, it doesn't matter which approach you use. If you're using the declarative style, then you do have to add an extra state variable to that component that is making the navigation decision, and you will find yourself using the redirect to component provided by the React router. If you're using the imperative approach, then we need to use this with router function that we saw last week, and we also need to use a special prop that is always available to our components, but we haven't used it so far, called the history prop. Now, a simple little use case for programmatic navigation is the following. Where you've got a website, let's say, and there's a registration button somewhere in the header, and I've implemented it twice now so that I can show you how I implemented it using the declarative approach and the imperative approach. But for both of these hyperlinks, I click on it and it brings me to the registration page, let's say. So that navigation is normal hyperlink based navigation. Typically, you'd have your form here that you fill out for your registration, and then you click the submit button. Now, this is where the programmatic navigation comes in. Okay, the event handler behind the submit button, it does whatever it does. Maybe it validates the data that you entered here. Maybe it communicates with a backend web API to store your data somewhere. But typically what it would do then is it would redirect you to typically back to the home page or to somewhere anyway. Now, this final piece of navigation here, this has to be implemented programmatically. It has to be implemented by, in this case anyway, the event handler behind this button. So I have this in sample 8. So if we quickly look at sample 8. So behavior is, as I said, I click on then I click submit, and I'm back to the home page, and both of the hyperlinks do the exact same. So we will look at the code in this case. So here's the home page, and here are the two hyperlinks that we saw at the top of the page. So I suppose if I take this one first, when I click on that hyperlink, it changes the URL to register D for declarative. That routing configuration, that URL matches this route entry here. So if we now look at the register declarative component, so this is the component now that's going to display my registration page and have the button and the handler for that button. I think I've imported that up here, but either way, here's the code for it. When you use the declarative form of programmatic navigation, you do need a state variable to help the component implement its programmatic navigation. So here's the state variable that I'm using in my case. It's going to be a simple Boolean, which I've initialized to false. We'll see how we use it in a second. Here's the registration page that appears. I have my button and my handler. And if we look at the handler then, it changes the state variable to true, which means my component re-renders. When it re-renders, the interesting part is here. When it re-renders, it checks the value of my state variable, see if it is true. And if it is true, then it does this. It returns the redirect component. Now, the effect of a component returning the redirect component, the effect of that is to cause the browser's URL to change to this value, and the routing configuration kicks in, or the React router kicks in again, and it makes a routing decision. So this is programmatic navigation implemented in a declarative way. And just go back again now. The very first time this component mounts, this is initialized to false, which means this expression is skipped over. So it doesn't do the redirect the first time, and it just displays my registration form. But then, as I explained, when the user clicks the button, the event handler runs, it changes the state variable, and we know what happens when a state variable is changed. The component re-renders, and because of the new value now, it re-renders, and in the second rendering, this now becomes active, if you like. So programmatic navigation, how we achieve it in a declarative way is using the redirect to component and using a state variable to allow my component to make the kind of programmatic navigation decision. That's the declarative way. The imperative way is implemented here. So this is the alternative implementation. And here's my registration form. Here's my click handler for the button. And in this case, what the event handler for the button does is this: props.history.push. Props.history.push has the effect of pushing a new value to the browser's URL address, and the value that I want to push is just that. I could put any path I want to, but I am pushing this new path onto the browser's URL. And of course, as we know, if the browser's URL address changes, then we know what happens after that. So this is a more imperative approach towards implementing programmatic navigation. This history prop is only available to you if you use the special with router function that I talked about last week. The effect of this function is to make the history prop available to any component that wants it. Just pause for a second, maybe. I know I'm going through at a fair pace, but is there any question I wonder about either of those examples? No. Right. There's one other routing sample that I need to look at, but I won't cover it this week. It will be, well, there won't be next week, but the week after reading week. But so what we've seen essentially in that final routing sample, there isn't anything new, I don't think, from a routing configuration and routing components point of view. It's just a particular use case for routing that's fairly common to all applications. So we've seen some of the aspects of the React Router library at this stage, and pretty much everything that we need to know to implement any type of routing logic. So what we've seen is that the React Router does follow the declarative programming model, in that we use particular components provided by the library. It supports component composition, which is one of these design ideas that I talked about last week. It very much follows the basic idea of React, which is when an event occurs in the browser, if that event causes a component to do some sort of state change, then the state change finishes up in a re-rendering. And that's really what's happening, as I said at the beginning of the lecture. When the browser's URL address changes, that's an event that's caught by the React router, itself consults its routing configuration, which is the event handling side, and it causes a re-rendering to happen in your app, which has the net effect of changing what page is currently displayed. So it does follow that kind of standard flow, if you like, that's part and parcel of React. The main components, some of the main components we've seen are these ones here. The WAD router had a special role as well, in that it made certain additional props available to our components should we need them. And I am saying here, all right, that you don't, there are hooks that come with the React router now, and the effect of the hooks actually means that you don't have to use the WAD router function. So if you start reading around articles on React router and you don't see this being used, but you see some hooks being used, which I haven't mentioned, these are some of them here, then that's what's happening there. Actually, I think a newer release of the React router library introduced hooks, mainly because the React framework itself introduced this hooks idea, so it kind of followed along. So in fairness, WAD router is a slightly older technique to use within the React router, but it's only a small part of our application anyway. Right, design patterns. I talked about them last week. They are kind of generalized solutions to commonly reoccurring problems, and they're all about really trying to achieve these objectives of reusability and separation of concerns. Reusability, in the case of React, would be we'd like to develop React components that we can reuse within an application or across applications. That's kind of a design objective. The separation of concerns is linked to that, in that we would like our components to have ideally just one central concern or focus, and each component's focus or purpose is separate from other components. That's the general idea of the separation of concerns. These are both programming design objectives, no matter what type of application you're developing. Linked to all of that is the dry principle. Don't repeat yourself. It's always a good idea not to have repeating code within your application. I then talked about last week about very high level approaches towards modeling a problem domain, either taking an inheritance approach or a composition approach. React favors composition. This idea of composing components with other components. Now, eventually we got to this list of 3 patterns that are very common when you're implementing React code. And I talked about the container pattern last week. This week, I want to talk about number 2, the render props pattern. So this is a pattern which we use when we want to try and share logic between components. Now, that's a very generic statement. The same could be said of the container pattern that I talked about last week, and indeed the third pattern, the higher order components. They all have the same kind of high level objective. The way you go about it is slightly different, and it can become just a decision that you as a developer has to make as to whether a particular problem that you're trying to implement a solution to, whether you should use the render props pattern to solve the problem, to implement the solution to the problem, or one of the other patterns that I mentioned. So let's just discuss the pattern in general first. And it's using the term, the pattern is called the render prop pattern. We know what a prop is. So it looks like the pattern is centered around using a prop for a particular purpose. And the definition there, definitions are never usually great, but let's try and break it down. We're told that a render prop is it's a prop which is a function. So you're passing a function to a component. We've seen that before actually, but this case the function has a particular purpose. So a render prop is a function prop, and we're saying that a component uses, so the component that receives this render prop, it uses it to know what to render. So we pass a function into a component, and the component that receives that function, it uses it in order to determine what it should render onto the screen. So if you like, the component that is passing the render prop down to its child, the parent component is essentially telling the child what it wants the component to render. Or more accurately, I suppose, it's telling the child part of what the child should render. That's kind of very unusual now, but it has its use cases. Here's a simple abstract kind of illustration and very simplified illustration. So I've got this component, which I've purposefully called that. It's the shared, I call it shared component. And you can see in the middle of its JSX, it's going props.render. It seems to be expecting a prop called render, which it expects to be a function, and it's calling it. And whatever that function returns, sorry, I'm pointing at the wrong thing. Whatever that function returns, that's going to be inserted into this overall JSX. Okay. Here I've got a component that is going to use the shared component. We would refer to this as a consumer. And in the middle of my consumer, I'm using the shared component above. I am indeed passing it a prop called render, and I'm assigning to that render a function. And that function returns some JSX. So this JSX that it is returning, that's actually going to be part of what is going to be rendered by my shared component up here. So the consumer or the parent is passing down via this render prop to the child. It's passing down a function, and the purpose of that function is to control what the child actually displays. So the net effect of this piece of code here is that what the shared component will render is the div with its on mouse over handler, wrapping the span element with the say hello text. So I'm saying the shared component receives its render logic from the consumer, which is the one on the bottom left. The name that we give to that prop, it's only convention that we call it the render prop, but it can be called anything else, but it's just a convention. If I've got a simple little example here of, this is back to our filtered friends, and whether these are two separate applications now or two different pages in the same application, we can see that what they're displaying is quite similar. On the left, we have a list of friends with the friends image, and on the right is a list of friends with the friends email. Now, clearly, there should be the possibility or the option of implementing this in such a way that we can have a component that renders a list of friends in some sort of way such that we can have kind of shared logic. Now, a few weeks back, we had this implementation of essentially the page on the right there. And this is the way we implemented it, if you remember. And what I'm highlighting in this implementation is the link between the filtered friends component and the friend component is very static, or is static, right? In that the filtered friends list component, the only type of children that it can control are children that render a friend in the way on the right there. Okay, it's a static relationship between these two. What we would like is for the filtered friend list component to be able to deal with both scenarios from the previous screen. So the problem with the design that we used in an earlier lecture is, as I'm saying here, that the filtered friend list component is statically bound to a particular friend component type. We want to be, it to be more dynamic. And the way we're going to achieve this is by using the render prop pattern. And as we'll see in a second in the code, essentially what's going to happen is this component here is going to pass down to this component a function, and that function will express the way a friend should be rendered. So this is now controlling how it wants a friend instance to be rendered on the screen. Here are some excerpts from the application. This application now comes with this week's archive. So what I'm looking at the top left here is the middle component in my hierarchy from the previous screen. Okay, this is the filtered friends list. And if you can remember this application from maybe, is it 2 weeks ago or last week, 2 weeks ago maybe, this filtered friends list, what it receives as a prop, or one of the props it receives, is an array of friend objects, and it's mapping over that. We've seen all that before. But the callback that we're giving to the map is now invoking another prop that's passed down to it, which I've called render. And it's passing to that function that's going to pass down to it. It's passing the particular friend instance. Item here is a particular friend instance. So the question is, what does this return? Because whatever this returns, that's what's going to be inserted into this array. And as before, it's just rendering the list of friends. It's rendering the friends array. Down here, I'm showing you two examples of usages of the component on the top. So here I'm importing a friend component type, and you can't tell from the name, but this friend component type is going to render a friend's name and their email. So I'm importing that in the normal way. And here I'm calling the filtered friends component, this one up here. I'm passing it my list of friends that I want to have rendered. And here's my render prop. The render prop is a function, as we know. And in this case, the function returns an instance of friend component, which is this one up here. So it's this friend component. That's what's going to be contained inside in this array up here. It's going to be an array of friend component instances where the friend component is implemented here. We know what the key, the purpose of the key is. That's just to ensure that each entry in this array has a unique key. And what's nice too about this function is that it's a parameterized function. It expects a parameter, and the parameter is going to be the friend object itself. And you can see what's happening up here when I'm mapping over my list of friends. I'm calling the function and I'm passing in item. Item is going to be a particular friend object in this list here. So the overall idea is, that this component here, it's rendering an array of friends, but the type of friend object that it's rendering is being controlled by this prop here. Here's a second example. In this case, I'm importing a different component. This is the component that's going to render a friend name and their image. And I'm invoking it in the exact same way. That's quite tricky now. The application itself, you get as an archive. And if I just quickly pull it into VS Code, Now, if we look at app.js, I suppose. So app.js is the component at the top of my hierarchy. Now, just for illustration purposes, I've got two import statements here, which I just enable and disable to demonstrate switching from one form of rendering a friend to another. So at the moment, this is how a friend is going to be rendered, and it's referring to this component here. Not terribly interesting, right? It's a component that just expects to receive a friend object, and it just renders a friend like that. Here's the other form of a friend component, which just renders a friend and a friend's name and their email address. So this is the component at the top of the hierarchy. The key part that I showed you was essentially here. The other code up here is all as before. I'm using the random user web API and all that, so there's nothing interesting there. So here's the render prop. And to demonstrate it being used, if I disable this and enable this and do my save, now it's rendering friends in a different way. The filtered friend list, we've seen that. Okay, so what's kind of different now in this filtered friend list, and I've purposefully left this import here. When we use this filtered friend list component before, we had a static import, which is this import here. So that meant it was always going to render a friend in a particular way. But I've commented that out now, and it would remain out. It shouldn't be there at all, really. Because now what's happening is friends are being rendered based on the render prop function that's being passed into it. Right. We will use that not in this week's lab. I think it's the following lab that we will use the render prop pattern to implement a particular aspect of our movies application. Just finally, the other pattern is this higher order component pattern. We're not going to look at it, but the basic idea is that a higher order component is a function that takes a component and returns a new component from it. And the component that it returns is essentially an enhanced form of the component that it receives as a parameter. And I'm listing here just the different possible enhancements that might be carried out by this special function. It may receive a stateless component and turn it into a stateful one, or it may actually provide additional props to the component that it receives, or it may enhance the UI of the component that it receives. So these are all examples of what a higher order component function might do to a component that it receives. We've seen one example of this pattern being used, which was with the with router function. That's an example of a higher order component function. What it did in particular was it made additional props available to our custom components. All of these higher order component functions, they all begin with the prefix with. That's just, again, a convention. And you'll see other examples of them if you read around React. They're kind of being deprecated now in favor of render props and hooks, to be honest, which is why I'm not going to cover it kind of formally, but you may come across it when you're reading around React. Right. So I've gone through stuff there at a fair pace, I admit, but you would see examples of particularly the patterns being used in the labs, and hopefully having an opportunity to see them being used in real life application will solidify your understanding of them. Is there anything special in this slide? It's just summarizing all that we have covered in relation to patterns so far. There is one other pattern that I need to look at. I may look at it on Wednesday's lecture, or maybe the following lecture after that. That's also going to be very important for our movies app. But I guess for now, time-wise, we're out of time anyway. Okay, so I've gone through a lot there, and as usual, you may need to review this in the recording. But for now, I guess I'll freeze it there unless there are any closing questions.
All good, Jim.
Okie doke. All right. So I'll talk to you again on Wednesday. Bye for now.
Thank you, Diarmuid.